Good day, matriculants. In this video, we are going to look at the sequences and series questions from the November 2018 question papers. So we have here question 2 and 3. Let's jump in. Before we jump in, I just want to mention this videos I'm making during lockdown due to coronavirus in South Africa to help the grade 12s to not fall behind. So for now, we are just revising through the term 1 work, sequences and series, trigonometry, Euclidean. You can join the channel if you're interested in revising with us. And then also set the bell icon to just get notifications when new videos are uploaded, so you can watch the videos as we work through them. And then when we are done with the term 1 work, we will also start with the term 2 work. I'll explain a bit more in detail while we are looking at the term 2 work, so you can also somewhere start doing that. I think the term 1 work, I'm just explaining the questions because you did this in school already, but the term 2 work I will somewhere explain properly the theory as well while we work through that question. So please join us if you have other friends in grade 12 that might also benefit from this. Please share the videos with them so that they can join us in working through our math and not falling behind during lockdown. Let's look at question 2. Given the quadratic sequence 2, 3, 10, 23. So question 2 starts with the quadratic sequence 2, 3, 10, 23, and without even actually looking at the question, I'm tempted to go and draw the pyramid there, but we can have a look there, write down the next term of the sequence. Okay, so yeah, this would have been a good idea. Let me just quickly see if I can refocus the camera quickly. Oh, there we go. Okay, so this goes up plus 1, plus 7, plus 13. And then I see it goes up 6 more than the previous one, so that should go up 19. Then 23 plus 19. I'm just going to use my calculator for purposes of double checking. My brain is so tired. Okay, so 2.1.1, write down the next term of the sequence. It's going to be 42. Then 2.1.2, determine the nth term of the sequence for quadratic number patterns. 2a is equal to 6, 3a plus b is equal to 1, and a plus b plus c is equal to 2. Alright, I use the formulas. 2a is this value, 3a plus b is this value, and a plus b plus c is this value. If you have another method that you're comfortable with and that you know very well and it works for you, that's perfectly fine. I know there are more than one method. So I start here working out the a, substitute in there to help me work out the b, and then substitute the a and the b in there to help me work out the c. Alright, so this is what negative 5, which I jump over, becomes positive 5, so 7. Then the general term is an squared plus bn plus c, or you can write it rather 3n squared minus 8n plus 7. And I just want to also check that it works. 3n, I'm going to make the n1 squared minus 8n1 plus 7. That's the first term, 2. The second term, let's make this 2. This just double checks that I haven't made mistakes, is 3. And the third term, if I substitute 3 in there, is going to be 10. So I can see I worked correctly. Sometimes we just make a silly mistake and then it costs us marks and it's so unnecessary. 2.1.3 says now calculate the 20th term of the sequence. So term 20 is going to be 3 times 20 squared minus 820 plus 7. Yeah, this question so far, very basic stuff. I don't think this is really a challenge for most of you. 1047. Okay, and then that's that. Okay, so the next question, 2.2, is given the arithmetic sequence 35, 28, 21. Calculate which term of the sequence will have a value of negative 140. Also very basic stuff. Arithmetic sequence. I'm going to use the formula a plus n minus 1d for terms. They want to know which term is negative 140. So I'm going to make my t negative 140. The a is 35 plus n minus 1, and the d, the constant difference. I can see it goes down minus 7, minus 7, minus 7. So my constant difference, negative 7, and then I must just solve for n, which I think also for most of you, pretty basic stuff. Minus 140, minus 35, jump that over, minus 175. And then n times negative 7 n minus 1 times negative 7 plus 7. So I'm also going to subtract from this negative 75, 7 minus 182. Minus 182 is negative 7n, and then divide by negative 7 both sides. So I have n is 26. Okay, that's 2.2, 2.3. For which value of n will the sum of the first n terms of the arithmetic sequence in question 2.2 be equal to the nth term of the quadratic sequence in question 2.1? What? Okay, if you read a question and you feel, hey, just relax. This is then a level 3 or 4 question. I don't even think it's a level 4 question. This is not that difficult, but just read it again. For which value of n, so I want to solve for n, will the sum of the first n terms of the arithmetic in question 2.2, the arithmetic in question 2.2, the sum of n terms. So of this pattern, the sum of n terms is going to be n over 2, 2a plus n minus 1d. Let's just substitute that in here. N terms is going to stay n because I want to solve for n. My a here was 35. So 2 times 35 plus n minus 1, and my d was negative 7. Okay, there's the sum of the first n terms of the arithmetic in question 2.2 is that will be equal to the nth term of the quadratic. So the nth term of the quadratic is going to be 3n squared minus 8n plus 7. So 3n squared minus 8n plus 7. The sum of the first n terms of the question 2.2 is equal to the term in question 2.1. I apologize for the background noise. My little baby is busy playing there. N over 2, 70. I'm just going to simplify this. N times negative 7, negative 1 times negative 7, and then 3n squared minus 8n plus 7. N over 2 times 70 is 35n. The over 2 is going to just divide. That's going to be then 7 over 2 n times n is n squared, and n over 2 times 7 is then, well, 7n over 2, or 7 over 2n. 7n over 2 and 7 over 2n, same thing, right? Is 3n squared minus 8n plus 7. Okay. Let's take everything to that side so that I have a positive n squared. I don't want to have the negative, so I have 0 on this side. 3n plus 7 over 2. 3 plus 7 over 2 is 13 over 2. So I have 13 over 2n squared, then minus 8n. Minus 8n. And then I want to jump over the 7 over 2, so I'm going to subtract 7 over 2 and subtract 35. It's going to be negative 93 over 2n. That's all of the n's, is minus 8 minus 7 over 2 minus 35n. And then those are all n's. Then I have the plus 7, and I don't like working with these fractions. You can, if you want, to just work with the quadratic formula from here, but I don't want to work with the fractions, even in the quadratic formula. So I'm just going to multiply by 2, multiply by 2, multiply by 2. So this looks better. Okay, and then from there on, use the quadratic formula. You can probably factorize this because the n should be a whole number. But I'm just going to use the quadratic formula. So the quadratic formula on your formula sheet, minus b is negative 93. So you must have both. The formula has a minus in and my b is negative. Plus, let's put the plus first, root of b squared minus 4a is 13, c is 14 over 2a, which is 13. And that gives me 7, or n is, if I make that a negative there, it gives me 2 over 13. So n is 2 over 13, which obviously the n should be a whole number as it's a term number. So this one is not applicable, but n is 7. So for which value of n is 7 is my answer there. Right, so that is question 2.3. We have left question 3 of this paper that we're quickly going to do. Okay, so question 3. A geometric series has a constant ratio of a half and a sum to infinity of 6. Calculate the first term of the series. Right, so since it is, the r is a half, which does lie between negative 1 and 1, the series is converging, and I can use the sum to infinity formula, a over 1 minus r. Okay, so it has a sum to infinity of 6. The a, I don't know. The r is a half, 1 minus a half. And then I must just solve for a to calculate the first term. So 1 minus a half is a half. So I'm just going to multiply the half on the other side. 6 times a half of 6 is 3. So the a is 3. Term 1 is 3. Right. Okay, 3.2. Calculate the 8th term of the series. This is then a geometric. So I have ar to the power of n minus 1. I have my first term. I want the 8th term. The 8th term, the first term is 3. And the r value is a half. The 8th term will be 8 minus 1 there, and I can just substitute into my calculator. So I have 3 over 128. 3 over 128. Right, that's 3.2. 3.3 says that the sum where k is 1 to n of 3 to 1 minus k, the sum is equal to 58125. 5,8125. Calculate the value of n. Okay, so I'm going to just start by substituting 1, 2, 3 in there and just generate a few terms. That just makes my life easier a bit. But some of you might be able to see my a is 3, and this is a geometric pattern with a a3. Just be careful because there's a minus k. The r is actually a half, not 2. So the a is 3, the r is a half, and I want the sum of n terms to be equal to 5,8125, and you can substitute straight from here into the sum formula for geometric and then work it out. But for most of us, it just helps to substitute in there 1. Then I have, let's use the calculator, 3 times 2 to the power of 1 minus the first term. I make that k1 is 3. The next term, I'm going to make that k2 is going to be 3 over 2. The next term, I'm going to make that k3 is 3 over 4. And then I see, oh, this is a geometric pattern. Term 2 divided by term 1 is a half, right? You can test term 3 divided by term 2, but this is a geometric pattern. I want to work with the sum formula for geometric because this means the sum of terms is equal to. So geometric pattern sum is a r to the power of n minus 1 over r minus 1, where the sum is 5,8125. The first term a is 3. The r value is a half to the power of n minus 1. The r value is a half minus 1. And then I must just solve for n. And I'm going to need to use logs here in this question, which some of you might not have done yet, but I'll explain when we get there quickly, briefly. They're not difficult. Okay, so first I'm going to just multiply. This is half minus 1, which is negative half. So I'm going to take that 5.8125 and multiply negative a half. I apologize for the background noise. I think I said that already. The little baby is a little bit sick at the moment, which is making him a bit grumpy. But his dad is there with him, looking after him at the moment, so he's not left unattended. Just by the way. Okay, so I multiply that on the other side, and then I'm going to get rid of the 3 here, so I'm going to divide the 3 on my calculator. So I have negative 31.30 over 32. Then I divided the 3 out, so now I'm left with this, and then I'm going to add the 1 on the other side, so I have 1 over 32 is a half to the power of n. Oh, you don't actually need logs, by the way. Because you can take 32 shift fact. Where is my fact button? There is 2 to the power of 5. So this is 32 is 2 to the power of 5. So this I can write as a half to the power of 5 is a half to the power of n, which means n is 5. But just for those of you that are interested to know how logs work, we're going to do it anyways very soon. If I have 1 over 32 is equal to a half to the power of n, what I can do is I take logs both sides, log, and then the log can, if it has an exponent, I can put the n, there's a log rule that says I can just jump the exponent to the front. So then jump the exponent to the front, n log a half, like that. And then to get the n alone, I can divide log 1 over 32 divided by log a half to get log a half, log a half. Okay, so that will cancel, giving me the n alone there. And then if I type in my calculator, I'm just going to use this log button there, not that one. So I use log 1 over 32, and like the sine, cos, and tan, it opens a bracket that you must just close over log log of a half, and there it gives me 5, which seems so unnecessary if you can do that. But if this couldn't factorize into something with a base and an exponent, that I can, if the answer was something like 4,72 or something, then I need logs to be able to do that. Okay, and that's question 3.3, the last question here. If the sum from k to 1, you see it's the same thing, but now it's from term 1 to term 20 is equal to p. Write down k 24 to minus k. There's something 1 missing and the 24 there in terms of p. So this sum is equal to p. What happened from there to there? I multiply every term with a. Do you see this term? This term 1 here. This is now problem solving. So 3.4 from the sum k is 1 to 20 of 3 to 1 minus k, that is equal to p. I want to move to the sum k 1, 20, 24 to minus k is equal to, I want to know what this is. So what happened from there to there is every term was multiplied by 8. So term 1, term 2, term 3 was multiplied by 8. And then that 1 means it was divided by 2. Can you see? Because the 1 is not there anymore, if I break this up in 2 to the power of 1 times 2 to the power of negative k, the 2 to the power of negative k is still there, but the 2 to the power of 1 is not there anymore. So I divided with 2 as well. Basically meaning I multiplied every term with 4. Do you see that? Okay, so every term is multiplied by 4. If I take the sum, this is going to be 4 times term 1 plus 4 times term 2 plus 4 times term 3. So this is thinking of the sum. I did take term 1, term 2, term 3, but I need 4 times term 1 extra, 4 times term 2, 4 times term 3. So if I take term 1 plus term 2 plus term 3, I'm taking a plus sum here, and I take the 4's out as a common factor, then I have term 1 plus term 2 plus term 3, what, up until term 20. So this sum is going to be P, then this sum is going to be 4P. Okay, and that's question 3.4. Right, so that is the sequences and series questions from the past question papers up until 2018. I hope this is helpful. Please don't stop working over the holidays and think over the lockdown and think that, oh, holiday. Please continue working because it's possible that the lockdown can also extend past the 21 day if we look at what happens in other countries. And I don't want your grade 12 year to be affected by this. So please don't stop working. Please continue to really take responsibility for your own learning, and let me know if you have any problems, challenges, questions. I will help as far as I can. Okay, good luck.